Okay, so we're going to look at what terminal points are and actually how to calculate particular terminal points in some examples. Let me shrink this picture down a little bit so we have a little more room to work. Okay. The axes didn't move very well, did they? So let's try to move the circle. There we go. That looks a little better. All right, so let's say we have a t value or a theta value, because in the unit circle the t is an arc length, by the way. You could use s or some other letter, but your arc length or your angle is, let's say one of our common angles, 5 pi over 6. Okay? So if it's a theta value, it's in radians. If it's a t value, it might be in a unit of length, because it's an arc length, so it might be like feet or inches or something. Okay, so let's move this axis up a little bit. So if theta is 5 pi over 6, here's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So here we go. This is our angle. And I want to remind you of another way to look at this. You could think of this as being 5/6 of pi. So here's pi. You cut pi into 6 pieces and you count 5 of them. So that's the same basic idea. Okay, so we're here. And now I want to know the terminal point. The key word here is point. Okay? A point is an ordered pair, an x and a y. So what I'm looking for here is this is a particular point, has an x and a y value. So an easy way to find those is to draw a right triangle. The same thing as a reference right triangle. To the center and down to the x-axis, so that this is a 90-degree angle, and these are pi over 6's, so this of course would be a 30-degree angle, and this would be a 60-degree angle, and we have a 30, 60, 90 that we recognize. Now the radius of the unit circle is 1, so this hypotenuse is length 1 because it's from the center to the point on the circle. If the hypotenuse is length 1, then that means in a 30, 60, 90, the short side is half of that, and the long side is, the long leg is the short leg times the square root of 3. So you have 1/2 times the square root of 3, which is the square root of 3 over 2. So this is the same thing as your x, and this is the same thing as your y, except that the x coordinate in the second quadrant over here is negative. So this x is negative, and your y is up, so it is positive. So the terminal point for this t value, or this theta value, the terminal point is negative square root of 3 over 2, comma, 1/2. Okay? Let's try a harder example. So now our t or theta value is negative 55 pi over 3. The easiest thing to do in this case is to rewrite it as a mixed number. 3 goes into 55 18 times, so you've got negative 18, with one remainder left over, so negative 18 and 1/3 pi's. Now negative 18 pi rotates this way, and negative 2 pi puts you back here. So negative 18 pi is exactly 9 revolutions and lands you right back where you started. So from here I just need to go another negative 1/3 pi, or pi over 3. So I'm just looking at negative pi over 3 from here. So pi over 3 is closer to the y-axis, so that's this point here. Okay? So now we do the same thing as we did before. Once we know our point, we need to get the ordered pair by drawing a reference right triangle, like this. And since this is a pi over 3, this is a 60-degree reference angle. And so the hypotenuse again is 1, so this is the 1/2 now, and this is the square root of 3 over 2. The 1/2 is to the right, so it's positive. The square root of 3 over 2 is down, so it's negative. So the terminal point in this case is x is 1/2, y is negative square root of 3 over 2. Okay? Now, students get confused by this last example all the time when t is 3 pi over 2. You don't have to draw a right triangle in this case. This point is 1 away from the origin because the radius is 1, so the ordered pair for this is x is 0, and y is down 1. So 0, negative 1 is the terminal point for a t value of 3 pi over 2.